access modifiers, right? So access specifiers, yesterday we have discussed access specifiers are those which specifies the visibility of a class, variable, or a method. In the same way, we have some other keywords which represents which are used to specify, which are called as access specifiers, right? Access modifiers, right? So these are the some more keywords we have. They are used to modify. So right. So these keywords are used to modify. Yeah. Right. So there are few keywords we have which are used to modify the natural behavior of a class, variable, and method, or anything. So few keywords are used in few areas. So whatever the general behavior will be there with a class or method or a variable, they are going to change this behavior. So they are called as what? Access modifiers, right? So here we have list of modifiers. Out of those, already we have discussed one access modifier, which is the most important one. And right, such kind of access modifier is already we have discussed is what? Abstract. So what is the abstract access modifier? What it does when it is applied to a class or variable? What it is going to do here, right? So already we have seen here this abstract. Still we have some other modifiers like this. You have one more important modifier, final, right? So we have some more, one more most mysterious again. There's a one special access modifier. We have static, right? And you have still more like a synchronized. You have still more like a volatile, right? Volatile, and you have a transient. You have seventh native. This is also one more access modifier, and the last one you have is strict. Strict. Like this we have different access modifiers, and each access modifier is used in different areas. So as the name itself says, they are going to modify the basic nature, whatever the basic general behavior will be there for a class or variable or a method, they are going to modify them, right? So out of these we have already seen abstract, right? So we have already discussed the abstract out of these. So what is this abstract? We summarize once here. So what is abstract and where we use abstract, right? So abstract is access modifier. Abstract is access modifier which will be used in two different areas, right? So what are the two different areas where the abstract is used? So abstract can be used with a class, or it can be used with a method, right? So it is abstract we can use with a method, absolutely fine, as well as we can use it with a class, right? So we have seen what is the meaning of abstract class and methods, right? So it cannot be used with any variables. There is no concept called as abstract variables. You will have abstract methods and abstract classes only, right? So abstract method is a method without any implementation. So whenever we come across this scenario, whenever you do inheritance, whenever in the superclass, if it is not possible to define a method, in that case we take a method as what? Abstract method, without writing any body, and this keyword forces the child class to implement it. In the same way, when a class is having abstract kind of abstract method, then in that case the class should be declared as abstract. So it is not compulsory that the class must contain abstract class must contain abstract methods. It is up to the class, right? So the general is the most the meaning is you cannot instantiate the object for abstract classes. If a class is abstract, you cannot instance the object for abstract classes. So these abstract classes forces the inheritance, right? So if it is contains any abstract method, right, the abstract method must be implemented in its child class. It forces the inheritance to be implemented, right? So this is already we have discussed. Now we'll try to understand the remaining access specifier modifiers, whatever we have here. The one more and most important is final access modifier. Final, right? So this final access modifier again will be used with the, it is used in three different scenarios, three different cases we use this final, right? So this final can be used with the three different cases. Here we use the final, we can use with a variable, final we can use with a variable, and we can use with a method. Absolutely, you can have a final with a method as well as you can have a final classes. Very important, final class. Final class is the one which is very important one, right? So what happens here, right? So what is this final? When I use this final, what happens there? So we try to understand here. So final is a keyword and it is defined some kind of access modification, access, which acts like access modifier. So what actually the modifies, what it modifies, right? So we are talking about up to now we are talking about instance variables or local variables, but whenever you develop any application, it is always required that you need to define some kind of fixed values in your application, constant values. Let's suppose if you take the example, now I'm going to develop application for a student, calculating the marks and all for a student. So there will be, in most general case, you will come across two boundaries for its marks here. So the marks cannot be less than 0 as well as the maximum marks will be 100. Now I want to fix such kind of boundaries, right? So in such cases we go for what? Now whenever you want to define some grades for a student, so generally the grades will have 4 to 5 grades, A, B, C, D, E kind of grades. So those are all those things never changes. So the grades are maximum mark or minimum mark, or if you take the currency symbols, right? So if you define a currency symbols, so you will have 10 rupees note or 20 rupees note, you will have 50 rupees note, 100 rupees note, but you don't have any 25 rupees, you don't have any 30 rupees kind of fixed values. So whenever you define such kind of fixed values, whenever you develop such kind of whenever you develop the applications, you will come across such kind of fixed values. And that means what? Non-modifiable values, they are always same. There is no there is no meaning of modifying these values, right? In the mathematics also we'll come across such kind of values. The most important value is pi, right? You'll come across one value which is always the same, pi value. So like this, whenever you develop the applications, somewhere in your applications you may come across some kind of fixed values, as I discussed, as I have given examples. So fixed values for what? Defining some kind of maximum mark and minimum mark, right? Defining some fixed bound grades. Always the grades will be A, B, C, D. No other grades you will have. So like this, you will come across such kind of values. So such kind of data, whenever you develop your application, you come across such kind of fixed values. So if you want to fix the values, non-modifiable, right? The values should not be modified. Once you have defined it, it should not modify it, right? If you try to change it, then it gives you an error. So in such cases we go for what? Final variable. So making a field as final, what happens here? Making a field as final, the value once it is assigned, it should not be changed in the future. If you try to change the value of this variable, the compiler will not allow you to do this. The compiler stops you to do. So to take such kind of constant values in your program, so we use final keyword. Okay, to take such kind of constant values, to define such kind of constant values in a program, we use final keyword. Once a variable is final, it cannot be modified in the future. If you try to modify its value, it raises you an error, right? So to define constant values in Java, we use a final keyword. The second is, final can also be used with methods. Final can also be used with what? Methods. What is the meaning of final method here? Very important interview point of question. Same as it's almost like whenever you take a final variable, the value of this variable cannot be modified. In the same way, whenever you have a method, and if this method is having only one implementation, there are no other alternates. There are no other alternates to write for this method. Like, to protect this method from overriding, right? To protect a method from overriding, then we go for what? Final methods. That means when I am writing method in the superclass and there are no other alternates for this method, only one version of this method is available. So nobody can write one more version. Nobody can re-implement this method. In that case, we go for what? Making a method as final method. It's up to you, right? So whenever you have a superclass, whenever you're defining a method in the superclass, and if you feel there are no other alternates for this method always, for any child class, right, any subclass, this method will be executed in the same way, right? In that case, to restrict the child classes to override, to restrict the child classes to override this method, we make this method as what? Final method. That is where you come across, right? So very important thing here to be understand here, final method cannot be overridden. Final method cannot be overridden. That means there are two things here to be noted. Is the final method can be inherited? Is the final method will be inherited? Can be inherited. That means final method participates in inheritance. Right? So final method can be inherited. Definitely final method can be inherited, but it cannot be overridden. So as we discussed previously, overriding means what? Right? Overriding means re-implementing. Right? Let's suppose I have a final A, class name is final A. Right? I'm saving this program. .java. I'm saving my program with .java in online classes. It's fine. Now I'm going to take a final instance variable, and the most important thing is local variables also can be finals. So whenever you talk about local variables, only one access modifier is allowed for local variables, that is final. Final or local variables. A final keyword can be used with local variables. No problem. You can use a local final keyword with the local variables, right? As well as instance variables. So here I have a final keyword. So whenever you make a variable as final, that means what? You are saying what? Whenever you make a variable as final, that means what? It has a value and it is a fixed value. So it is always recommended when you declare a variable, there itself assigning a value for this is always recommended, because whenever you are making this as final means what? There is one value and it is fixed value. So in generally it is a standard. Actually it's not compulsory to do this. So whenever you want to take a final variable, at the same time you assigning a value to this is meaningful, right? Now here I am writing one more method here, final method, final void method, right? Now just I am going to write a system.out.println, oh yep, println of something here, final method cannot be overridden. Final method cannot be overridden. So just I am writing a message here. Now I'm going to create a child class for this final class A. So how to create a child class for this? I'm going to take one more notepad here. Final B, final class B extends A, final A, right? So B class extends A. Now in the B class, B is a child class for A. Now I am writing a main method inside the B class itself. That's your choice. If you want to separate it also, you can separate it. Public static void main, right? String args. So what is my child class is having? My child class is having, it is trying to override the final method. See there, same method I have in the child class also. So that means what? My child class is trying to override the final method from the superclass. Now my child class name is final B dot Java. Now I would like to compile my B class, right? So let's see what it is going to happen here. Java C final B dot Java, right? So what it is doing here, final B, is it correct? Yeah, Java final B. It's fine. Where is A class? Save the A class and save the B class. System.out.println of B class main method. Right. Okay, fine. Let me recompile my program. Final B extends A. Final A. It's fine. Right. Now, just I would like to make some changes in this public final method A. Public final void method. In the same way, I'm overriding this public final void method. See, it is saying what? It is saying what now? Method in final B cannot override method in final A. So final methods cannot be overridden. If a method is final, it cannot be overridden. Right? So final method, so final keyword restricts a method to be overridden. Right? So whenever you have a final method in a superclass, it cannot be overridden in the child class. But the question is this method is available to the child class? That means what? Is this method can be called? So I have removed. So you cannot re-implement the method in the child class. You cannot re-implement the method in the child class. But my question here is the superclass method can be called through the child class object? So is it possible for me to call this method through the child class object final B, fb is equals to new final B and fb dot what is it, method? Can I call this? Is it allows me to do? Is it allowed? Final fb. So through a child class object, it is already, we have seen that, we have learned that in the inheritance, a child class, through a child class object we can call what? Superclass methods. Now is this allowed me or not to writing like this? One is restricted there, you cannot override it. Now is it allowed me? So what I am doing here, I have created a child class object, and through that child class object I am trying to call superclass method. Is it allows me to do this? Right? So that is where here the key point here. So method is okay. See here, method is inherited. Method is inherited means what? Method is available to B class. The superclass method is available. Superclass final method is available here, but the child class cannot re-implement it. See here, I am able to call the superclass method by child class object and it is executed. Final method cannot be overridden. This is the output I am getting from what? Superclass final method. So method is available. Method is inherited, but method cannot be re-implemented. Getting me? So we are talking about overriding. When you talk about overriding, first method should be available to the child class. First the method should be available to the child class, and when the method is available to the child class, re-implementing that method in the child class is called as what? Overriding. It is also same here. The method is available to the child class, but in the child class you cannot provide the re-implementation. So final methods are inherited. but you cannot re-implement them. You cannot re-implement them means what? You cannot override them. That is what here you have. Okay. Okay, what I'm saying, did you understand here? So final method is overridden, inherited, but it cannot be overridden, right? So whenever you define a method, if this method has no alternates, then making this as final is always recommended, right? So if my class is, let's suppose, assume that my class is having here 5 methods without overriding. It's not possible to override the five methods, so that I'm making it as what? 5 methods as final, and there are 5 methods which can have implementations. So in this case, what I do here, 5 methods does not have any implementation, so I make them as what? Final methods, so that nobody can override them, and 5 methods can be re-implemented. The other 5 methods can be re-implemented, so that I am not making them as what? Final methods, right? But if all 10 methods are, I have, let's suppose, 10 methods, and these 10 methods are not having any implementation, no any other implementation, only one fixed implementation for each and every method. So what should I do? In that case, what should I do? My class contains 10 methods, and all these 10 methods are fixed implementations. Right? So in this case, if your class is having all fixed implementations, all methods are fixed implementations, in that case, we make the class itself as what? Final. Instead of making 10 methods final, we can make the class itself as what? Final. So what is the meaning of making a class itself as final here? That very important interview point of view question. Is it possible to create a final class? Yes, you can absolutely create a final class. So what is the meaning of creating a final class? In what scenarios we go for a final classes, right? So the first restriction, whenever you use a final class, right? Whenever you use a final class here, right? The class methods are not having any alternate. All the methods of a class are fixed. Each and every method of a class are having what? Fixed implementations. There are no other alternates for these class methods. In that case, we make the class as what? Final class, right? So that means when you make a class as final, this class cannot be, it's not possible to create a child class for that class. When you create a final class, right? When you have a final class, you cannot create a child class for what? Final class. It is not possible. Absolutely, it is not possible to create a child class for what? Final class. So that means what? It restricts inheritance, right? So what is the example for this? One beautiful class is there to clearly understand this. There is one class is there which is already I have told you to practice. I don't know whether you have practiced it or not. Java.lang.string is a predefined class, and the creator of this class made this class as what? Final class. Who created this class? See this syntax of this class: public final class string. So why the people who has created this class, they made this class as final? That means what? If a class is final, you cannot create a child class for this. Why why the developer of this strict class made this class as final? What is the reason behind this? Right? So the class has some methods here, and all the methods have only one single implementation. So if you see this string object, if you have a string object, I'm going to create a string class. String class means what? Whatever you create for this, they are called as what? Objects. Right? Hello, let's suppose. Now because the class is made as final, that means nobody can extend this class. If anybody extends a class, what is the problem? If anybody can extend a class, what they can do here? In the child class, they can rewrite the methods, re-implement the methods of the super class that we have that what we have seen, right? If any class is inherited from a super class, the child class can re-implement the methods in the super class. Now let's see this scenario here. Now there is a length method in the string class. What is this method is going to do here? Generally, it is going to take the string as input and it calculates the length of this string. Are there any other versions you will have? Are there any other implementations you will have for this length method for a string? In the universe, any Java programmer wants to calculate the length, there is only one way. There is no other way of calculating the length. Right? So there is no other implementation for this length method. It is only one implementation you have. So like this, whatever the methods we have in this class, all methods are having only single implementation. All methods are having what? Only single implementation from this class. So to restrict re-implementing these methods, class itself is taken as what? Final. If a class is final means what? Some other programmer cannot create the child class for this. So if no programmer can create the child class for a class, that means what? There is no possibility of re-implementing the existing methods in the child classes. Getting me? What I'm trying to say here? Okay? Getting me? What I'm trying to say here? If you see the example here, string class is a final class. The programmer who has developed this class, he made this class as what? Final class, because all the methods of this class should give the same kind of execution for anybody in the universe. Anybody who uses a string object, this length method is same. Its execution is always same. There is no other alternate for length. So if this class is not made as final, what some other programmer can do here? If this class is not made as final, what some other programmer can do here? He can create a child class for this class and he can re-implement the length method. Is it correct thing to do? No. So to restrict some other programmer to create a child class, right? The class can be taken as what? Final class. That means if a class contains the methods and all these methods are what? Fixed. In all cases they should work in the same way. Then in that case we make that class as what? Final class. The best example is string class. String is a final class. Why string class is final class? Right? See the methods of this class. All are like this. Is empty. Is empty means it checks whether the string is empty or not. Is there any other alternative we'll have for this is empty method? No. Character it. If you have a string, if you have a string object, in that string object it takes the index position and it returns the value from that index position. Right? So like this you have. If a class is already, if a class is having all such kind of methods, each and every method is having a single implementation, like no other implementations, then making that class final as what? It's good to make the class as final. The string class is very good example for this scenario. Did you get me? So what is this final is going to do for you? What is this final will do for you? So it is changing the natural behavior of a variable, method and a class, right? Right. So here that is the meaning of modifying the access modifiers. Such kind of keywords always modifies the existing behavior. So when it is applied to variable, the value cannot be modified. When it is applied to a method, it cannot be overridden. If it is applied to a class, the class cannot be created a child class. So it is not possible to create a child class for this class. So that is what you have here. So that is what you have here. Did you understand this final most important keyword? Do you have any questions? So that if you don't have any questions, we can move forward. Right? Okay, shall we move forward to one more keyword? Everybody understood? What happened, guys? Replies. Expecting replies. Only one reply. There. Okay. Now my question is, okay, before moving on to the next concept, I would like to ask one simple question. So, as we have seen that the combination of two things are okay, like the combination of access specifiers and access modifiers is absolutely allowed, right? So the combination of access specifiers and access modifiers are absolutely allowed. So I can have public final class. What is if I write a final class B? What happens here? Can I write a B class as final class? Can I make a B class as final class? Is it possible making a class B as final? No. Why? Right? So it is absolutely valid making a final B class as final. So if I make a final class B class as final, that means what? You cannot create a child class for B. Superclass is not non-final. Superclass is non-final. It's absolutely fine because my A class is not final. So A class can be inherited. But what is the problem? B is final. If a B class is final, then that means what? You cannot create a child class for B. Right? You cannot create a child class for B. So if you write some other class, public class C extends final B, public class final C extends final B, then that is a problem. Now one more question here. I'm expecting some answers for this. So is it possible to write a, so this final keyword, so if you see this architecture, this final keyword can be used with a class, and the same way the abstract keyword also can be used with the class. Right? Is it possible to write a class with these both keywords? That means public abstract final class. So it is absolutely valid. You can mix the access modifiers. Now my question is, can I write a class or can I write a method with both? Can I write a method with both or can I write a class with both? Abstract final class or abstract final method? Give me the reply fast. Is it possible to write abstract final class or abstract final method? Huh? Okay. So it is absolutely not valid to use both together, abstract and final. It is not possible because if you take the abstract keyword compulsory forces what? Inheritance. Final will not. Abstract means what? A abstract class must be created a child class. Final class must not be created a child class. Abstract method must be overridden. Final method should not be overridden. There's a very simple point here. It's not a complex point you have. Abstract class must be inherited, but final is abstract 100% opposite to this. Abstract method must be overridden. but final will not encourage overriding, so they cannot be used together. Absolutely wrong thing to use final and abstract. It is not allowed. If you try to use them, the compiler will raise you an error. Getting me? Okay. Simple fundamental technical rules, simple fundamental syntactical rules, right? So one definitely requires inheritance, one is completely against to inheritance. One definitely requires overriding, one is completely against to overriding. So that you cannot mix both, right? So this is what you have. And the most uh, mysterious and access specifier, and which also introduce leads to a new concept today, that is what? Static. The bit confusing one, right? And just focus here, and which leads to a new concept, static. Now here, what about the static, where I can use? First let me describe where I can use, then we try to understand how to use it. So it can be used in 4 different areas, not 3 or 2. There are 4 different areas you can use this static, right? First you can use this with absolutely you can use this with variables, right? As well as you can use this with methods. Yes, absolutely correct. Most important and most confusing, right? And you can have a class, absolutely. And the new one here is static block. We are writing some blocks here, main block, class block. In the same way you can write a block, but the class, whenever you apply this keyword to a class, this is applicable for only inner class. These are the 4 different areas you can use this. Getting me? Okay. So what is the need of this static variables? What is the need of static methods? What is the need of static blocks? We try to understand. We see about the classes. Whenever we come across inner classes, there we try to understand what is a static inner class, right? So this is what you have here. Now what actually static variable? Where I should go for static variables? What is the need of static variables, right? So to demonstrate this, just let me write one simple program here. Just let me write one simple program here, and through that program we'll demonstrate it. Right here, this is the program I have. Now let me just, for understanding purpose only, this program, it is not again exact example I'm trying to give, right? Now see this program again. I'm going to write a simple class here, public class. Let's suppose any class, just as example only I'm taking. There is a class called as account class. Already every day we are taking the same here, right? Int SCC number. Now int like this, some variables I'm taking, right? Now I'm going to take one more instance variable here. I'm going to take one more instance variable here. That variable name is string variable. Let's suppose I'm trying to create the accounts for the same bank. So the name of the bank name will be same for each and every account holder, so that I'm initializing this here only, because I'm feeling like this name will be same for each and every account holder, so that I'm going to take this name as HDFC. So because it is common to everybody, so I'm making this as what? Final. This is my class design, right? Right. So this is what we have: public class account, account number, account name, and string. So what happens here, if I create the object for the account class, how many instance variables have? 3 instance variables, right? So let us try to picture it. Let me represent it in graphical way so that you can understand here. Now let's suppose I have created account 1. If I have created account 1 object, what is this account 1 object will have? Account 2, account 3. There are 3 account objects I am trying to create. Assume that. And what this account object will have? First account object will have second account object, third account object, right? So this is second account object, and there are 3 account objects, right? So what each and every account object will have here? What each and every account object will have here? Account number, okay. Still name and bank name, right? So we have 3 instance variables, so each and every object will have these 3. The first one is SCC number, second one is name, and the third one we have is bank name, right? So in the same way, SCC number for this also, name for this also, and bank name for this also. Same for this also, right? All objects, every account object will have these 3 instance variables, name and bank name. These 3 instance variables will be there with each and every account. But if you see my class, I have defined the value for bank name. I have defined what? The name for bank name. So what is the meaning of this now? It is final, so fixed value. It is final, and I have already assigned a value for bank name. So what happens here? Whenever the object is created, so already there is a value in this. What is this value? Some value is there inside this SDFC. So there is a value inside this for this field. In the same way, it is also having a same, right? SDFC. For this also we will have the same field name SDFC. Right? So every object will have the same field because I have initialized it. Because I want to have the same common name for each and every account. It is the reason why I have initialized. So now can you see, is it correct thing to do or is it wrong thing to do or what it is? So if we create 1000 account objects, what happens here? 1000 account objects will have 3 common fields, 3 fields: account number, name and bank name. But account number and name will be different, and bank name will be same for each and every account object. So is it correct to write? Yeah, it is by default, it is SDFC. So this is what I have. If I create 1000 account objects, what happens? Each and every account object will have a bank name as SDFC only. So can I improve this? Is it correct design or is it correct to write it as final? Absolutely correct to write it as final. But if you see my 3 diagrams here, I see a small mistake in these 3 diagrams. What is the small mistake I have in these 3? According to my class, this is fine. But still, I see a big problem inside these objects. So what is the problem I have in these objects, right? So this is the problem here, the memory wastage. What is the meaning of memory wastage here? Now if I create 1000 account object, 1000 account object will have what? This field with the same value. Bank name will be there with 1000 account objects. Okay, it should be there. I'm not saying it should not be there, but with the same value. When I have 1000 copies of bank name with HDFC, it is not correct, I think. What I can do here, instead of having each and every bank name, one copy of this field in each and every object, I can do what? I can do what? I can separate it. I can separate this field. I can separate this field, right? And I can write like this, bank name, right? I can separate this field. I can separate this from the each and every object, right? And now what is the value I have for this SDFC, right? Right. So what I'm going to do here, because see, the understand the concept here, because this is the common one. Because why I'm separating this, I don't want, because every object will have the bank name, every object will have bank name. It is correct, but the problem is the value of this bank name is also same for each and every object. Getting me? So every object will have account number, but what is the case with this account number? Number will be different from what? Each and every object. Name will be there with each and every object, but what is this? Name will be different from each and every account object. But the question here is, bank name will be there each and every object, but the value to this bank name is same for each and every object. So what should I do here? Instead of creating multiple memory copies of each and every account object, what I'm going to do here is, I want to have only one copy of this bank name. I want to have only one copy of this bank name, and this copy should be shared with all these objects. Getting me? What I'm trying to say here? Do you understand what is the problem in those objects? So bank name should be there with each and every object, but the problem here is the value also should be same. When I have a field with the same name, when I have a field with the same value, so why should I create this field with each and every object? Instead of that, I'm going to create only one, and this common copy will be available with all objects. Did you understand here? No? Yes? Now what happens if I create 1000 account objects also? What will be there? 1000 account objects will have one common copy bank name, and each and every account will have its own account number and name. So what I'm doing here, what is there? Memory will be saved here. How the memory will be saved? Instead of allocating for each and every object, allocating bank name with the same value. If the value is different from object to object, then that is a different case. I'm not talking about the different values with each and every object. I'm talking about the field which is having the same value for all the objects. Then instead of allocating bank name with each and every object, what I'm going to do here, I want to create one memory location, right? So then I want to create one memory location, and this memory location should be accessed with all the objects, right? So how to create this separate memory location? That is the point here. How to create this separate memory location? So that is where we come across the keyword called as what? Static. That is where we come across a keyword called as what? Static. Did you understand here? Static means what? Right? So here, let me take this account class. Let me save this account class first of all, so that you can understand this, right? So what is the meaning of this here? We try to understand this. Now let me create a main class for this, right? One more class, Java class I'm going to create, so that I will try to access that main account main from that. Just I would like to create account objects, and from that I would like to access a account main class. Right? So what I'm going to do here is, so I'm going to make public static void main, right? String args. Observe this carefully. So what is the meaning of static variable here? Only one copy will be available for all account objects. Shareable copy for all account objects. That is the meaning of static variable. Yes. Right. So here see this. It is going to allocate separate memory for all, and all account objects can access that memory. Now see here what I am doing is I am creating a one account object. ACC1 is equals to what? New ACCOU NT. Right. Now what is this ACC1 will have? System dot. Now just try to concentrate your mode because this is a bit confusing example. So that right, ACC1 dot, what is it? B name. What it is? Account 1 I have created and I am trying to access the bank name. ACC2 dot ACC2, and again I am trying to access this bank name with ACC2. So because I have initialized them SDFC in both, absolutely. In both cases it gives the SDFC because the value also already initialized. That is a different story. Let me modify my program, then you will try to understand it. That answer is absolutely correct. I will get in both cases SDFC only. Now let me compile and execute my program. Account main. Account main.java. It's fine. There is no problem with this class. So in both cases you got SDFC, but how you prove it? It is a common copy for both. Right? So I'm going to remove this final. So what is the meaning of static? Only static I have applied. I am saying this, when you use a static with a instance variable, right, it creates a what? Common copy. It is also still it creates a static means what? Only one copy. Only one copy for all objects. Right? Now this is what here the diagram it is. Now this is what we have here. Now let us assume this. So this is account 1. Let us assume this is ACC1. Right? Which one? This is ACC1 and this is ACC2. Like this I have different objects. Right? And this is ACC3. So what I am saying here, each and every account will have their own copy of account name, and each and every object will have their own copy of account name and account number and name, right? And but each and every object have a common copy of what? Each and every object has a common copy of what? Bank name. Are you getting me? Are you getting me? Yes. So that is my I'm trying to explain. So if each and every account has a common copy called as what? Bank name. So already we have seen that. So what is this here? I can say what? One memory location can be referred by ACC1, ACC2, ACC3. This is all already we have seen. So there is one memory location which is referred by 3 references. Yes or no? So what are 3 references which are referring to that SDFC? ACC1 is referring to that, ACC2 is referring to that, ACC3 is referring to that. My question here is, see here. So if I modify, let's suppose if I modify this value with one object reference, what happens? Now I would like to change this ACC1.bank name. What I'm going to do here, ACC1.bank name, I will change it from SDFC to, let's suppose, ICSI. What happens here? It should reflect in all objects or not? Getting me? Yes. Now if I change ACC1.account number, there is no change in what? Account 2 or account 3 account numbers. Getting me? In the same way, if I change ACC1.account number, there is no effect on ACC2's and ACC3's account numbers. But if I change the bank name, if this memory location, if this bank name is referred by all references, it should reflect in all. Right or no? Now let's see here. Now I am going to access in the same way. I am going to access both fields we try to access. What is the first field? Bank name. And I'm going to access what? ACC number of account 1. In the same way I'm going to access a. So what I will get, because I did not initialize the account number, you will get what? Default values for both objects. Yes? Yes or no? See there, you will get default value SDFC, default value SDFC, right? Now I'm going to modify both. Through what object? I am going to modify ACC1 dot number. I am going to make it as what? 1. So wait, what account number will be modified here? What account number will be modified here? ACC1's account number will be modified, but there is no impact on ACC2's account number, right? Now in the same way, I am going to modify ACC1 dot bank name, right? So if it is modified, if it is a common copy, that should be reflect in what? ACC2 also, right? ICI. Getting me? Now I would like to print. I would like to print ACC2 values. I modified where? In what object I have modified? I have modified the values in account 1 object. Now I am printing the values of what? Account 2. Okay. Are you following me here? What I am trying to do? What experiment I am trying to do here? Everybody follows this? Right? If it is a common copy, I am saying that this is a common copy. If this common copy is modified by one reference, it should reflect in all, right? And I am saying this is not a common copy. It is unique individual copy to what? ACC1 only. Let's see what happens to my program. I did not modify the name of account number. It's not number, it is ACC number. It is not number, it is ACC number. Only one error. It's fine now, it is executed. What I got here? See, account 2's account number is not modified. See here. Why account 2's account number is not modified? Account 2's account number is still 0. But account 2's bank name is modified. Why it is modified? Did I modify the bank name? Getting me? Regard what happened there? No, yes. No. Okay. Please now let us represent pictorially. Right. So what happened here? When I write this statement, ACC1 dot account number. ACC1 dot account number means what? This area will be modified. What? Which one? ACC1 dot account number means what? Which one will be modified here? The copy in the account 1's account number, right? So this one becomes what? 1. This one becomes 1, right? Yes or no? And ACC2 dash account number is still 0. This one is still 0. But when I modify ACC1 dot bank name, this is changed. When it is changed, what happened here? Every object which is referring to this memory location is modified. ICI. It is changed to ICICI. Every object which is referring to this is modified. Did you understand? So what is the meaning of static here? Can you explain what is the meaning of static variable? So whenever you have objects and inside all the objects, if you have a variable, so every object will have what? Every account object will have these 3 fields. Every account object will have these 3 fields. But the problem is this field's value is also there and this value is common to all objects. So why should I create multiple copies of this object, this variable? Instead I can create only one copy. Right? If I don't use this static, what happens here? Now see this, if I don't use this static, what is the meaning of this? What is the meaning of this? Each account object will have its own copy of what? Bank name. Now let me run the same program. Still, see this, account 2's, what is the value you have in the account 2? SDFC. Why? Because I have modified the bank name in account 1. Did you understand? Everybody? What about others? Yes. Still I have to get the answers. Right? So like this you have. So if you don't make it as static, what is happened here? What is happened here? It is each and every object will have its own copy of bank name, and I modified in account 1, it is modified in account 1 only. But when I made it as statica, it is common copy for all. So only one memory will be created for this, and this memory will be shared by each and every object of that class. Right? So generally, so this is what here. So that generally this is a valid combination here. Static means what? Static means only one copy, but this copy is modifiable. As in the previous example, I modified its value. If it is modified, there is no meaning of this, because I want to have, when I have a fixed value, it should not be modified. That is the reason why I go for what? Fixed value. So whenever you have final, means what? Fixed value. Whenever you have a final value, making this as a static is absolutely recommended. Now what is the meaning of overall this variable declaration means? What is the meaning of this overall variable declaration? A single not modifiable copy with each and every account object. Yes, a single copy, that is static, non-modifiable copy, that is final. Because this SDFC should be fixed for each and every object. So what is the meaning of modifying it? If it is modifiable value, then I don't take it as final or static. Getting me? So whenever you have come across final variables, final instance variables, most of the cases people make them as what? Static. Instead of creating multiple copies with each and every object, they create to create only one object and shareable copy with what? All the objects. Is it meaningful or not, making this like this final static? That's your choice. That's absolutely your choice, right? So you want to take only final variables, you can take it. If you take only final variable, what happens? Each and every object will have its own copy of bank name. If you take static final, then only one copy, non-modifiable copy. If you take only static, that is also valid. Only one copy, but it is modifiable copy. If you take only static means what? It will create you only one copy of this memory, but it is modifiable. So it is most appropriate case to take final variables, final instance variables. People take them as what? Static final variables. Right? Okay. Do you understand this? So that I can move further. Yes. Now my question is very important concept here. I started in one different way, and I am going to end this concept in some other way, right? So my question is here, when the memory will be allocated for this variable? When the memory will be allocated for this variable? That is the question. No way of allocating the memories at compile time. It's wrong. Compiler will do what? Just code conversion. From what? Human understandable format to machine understandable format. That is only compiler is going to do. No memory allocations. All memories will be allocated when you run the program. Right? So you know that when the memory will be allocated for these two variables, when the memory will be allocated for these two variables, account number and account name, when the memory will be allocated for these two variables. Hmm. Very simple question, guys. When the memory will be allocated for account number and account name? Very simple question. You don't give the answer for this, no meaning. These classes, how many classes we have discussed, all no meaning. Hmm? When the memory will be allocated for account number and account name? Runtime only, that's correct. But when? What is that statement which creates the memory for this? I'm not asking the time. I'm asking at what statement? Right? So the memory will be allocated for those two fields for each and every account object when you create. Getting me? Simple, right? What is there? When you create account objects for each and every account object, the memory will be allocated for those two fields. Yes or no? If I create 1000 account objects 1000 times, this memory will be allocated for those two fields. Then what is there to tell? Very simple. Since starting we are learning the same thing. Huh? So when this memory should be allocated for this variable? Think and give me the answer. The last one. Because it is a common copy for all objects, that's what I am saying. So when the memory will be allocated for this? Yes. Only one copy will be created, that's absolutely correct. But when? First time when you create a account object for the first object? Runtime only. But when? So somebody is saying when I create a first account object, then it is going to allocating the memory. But how it knows this is the first account object or second account object? Because it is a common copy. So this, according to this diagram, I am saying what this is the common copy. So this memory should be this variable should be there in the memory before the first object is created actually. So because when I create the first object also, this should be allocated. So the question is, this memory will be allocated at the time of first object is created or at the time of before first object is created? When we create the first object, right? So not like this. So it will be allocating the memory. So very important thing, the static variables will be loaded. The static variables will be loaded into the memory at the time of your class is loaded. So as we discussed, first classes will be loaded into the memory. Once the class is loaded, only the runtime can access the fields of that class. So at the time of class is loaded, see this very important point. At the time of class is loaded, then the memory will be allocated for these fields. Getting me what I am trying to say? I will prove it. Don't worry. At the time of class is loaded, the memory for this variables is allocated. So that means what? What I am trying to say is, so whatever the common copy I am saying for these objects and all till now, of course this is a common copy for all the objects, but the memory will be allocated for this when the account.class file is loaded into the memory. When you try to run your program, so first classes will be loaded into the memory. When you try to execute your program, first the classes will be loaded into the memory. And when the account.class file is loaded into the memory, at the time this memory will be allocated. So that means what? What I'm trying to explain here, right? So before any Java object means not any Java object, before any account object is created, this is already there in the memory. Yes or no? If you want to prove me, I can prove it now. Right? How? Right? See this. It is the Java runtime is going to do when the class is loading. At the time of Java runtime is loading this class, it tries to see what static variables are there. Then it loads the static variables first. So what is the difference between this? These two variables will be loaded when you write new account. Getting me? These two fields will be loaded into the memory when you write new account. That means object creation. And this will be loaded automatically at the time of this dot class file is loaded. Right? So if you want to see here, now what I'm trying to explain is, now if you want to see the backend process, Java-verbose we can use account main. So somewhere the account class will be loaded into the memory. Where is it? Loaded the account class. So in that case, now I'm commenting the all statements from my main class. I'm going to comment all statements from my main class here. No objects creation, nothing, no object creation at all. Everything is commented, right? It is simple plain class, right? R. Now I'm going to write one statement inside this. I'm not going to create any object for this. Account A is equals to what? Null. To load that account class, I'm writing this statement because I want to load this account class in the memory, so that I'm writing this. Whenever it comes across account, then it loads the class. Let me see the same statement here. Save this and compile it. I did not save it. There is a problem here. It's a very important point and very confusing point, guys. Now when the account class is loaded, somewhere you can see account main loaded, and at the same time somewhere you can see account is also loaded. No account is loaded. No, account class is not loaded here. No account class is loaded here, right? So at the time of account class is loaded, this variable will be loaded. So I'm going to write one statement, see this, so that you can understand what is the meaning of this. I'm saying before any object is created, that will be already there in the memory. So technically speaking, to access that variable, no object reference is required. Now how I am accessing that name, see this, bank name. What I am doing here, very interesting thing I am doing here. What I am trying to do here. And if you want to call a dot name, is it allows? If I try to call a dot name, is it allowed? A dot bank name, is it allowed? See these two statements and tell me, is it allowed? A dot bank name. What is A is having? A is not having anything. A is a variable, nothing. It is pointing to nothing in the memory. Null. Still, how can you access it? Right? Let's see here. A is null. If I try to access account number, is it possible? A is not pointing to any memory. It is simply null. Now, if I try to do this, what is it going to do here? What is it going to do for me? Compile it. Saying what? Boss, you cannot access something from A because A is not pointing to anything in the memory. Nothing is there to access from the memory. Right? It is saying what? I'm sorry, you cannot do this. Because A is not referring to any object in the memory, so that you cannot access what? Account number. But here I am trying to write bank name. Is it allowed? A dot bank name. No. Let's see. Let me compile this, save it. I think I did not save it. Is it correct? Yeah, fine. Let's see, is it allowed or not? Saying the same here. What it is saying? Null pointer exception. Fine. I should not get this null pointer exception actually here. Fine, let me try to run this. So what it is going to do, let me see. Why it is non-static variable? I made it a static, right? What is the problem? Is it non-static variable? No, right? There is a problem in the class creation. It's fine. Now see this previously that was a problem here. Now I'm trying to access this by using A. I'm trying to access this by using what? A. See here, A dot B name. Is it allowed? No. Right? Allowed or not? Yes, why it is allowed? That is the meaning here. Now if for your I will change this name so that you can see, because if you are having a doubt here, so that I'm modifying the value inside this. Now I'm not going to modify main class here. Still A is not pointing to anything, and through A I'm trying to access some variable, but A is not having any memory allocated for A, right or no? Now let me access this. Let me compile this program. It's fine compiled. So you got ICSA? Yes or no? What does it mean? What does it mean? So before any object is created for account class, it is there in the memory. Yes or no? Do I created any object here? No object I have created. A is not referring to any object. Yes, account is a data type, absolutely. Account is a data type, user defined data type. Now can I do the same thing with the account number? Can I call account number with A? You cannot call account number with A. It shows you an error. Why? Because account number should be loaded into the memory. Account number will be loaded into the memory whenever you write what? New account. Getting me? Whenever you write a new account, then only account number will be loaded. But if you don't create the object also, still there are some variables will be loaded into the memory. They are called as what? Static variables. Getting me what I'm trying to say here? So to access this bank name, do I require an object? No. Absolutely no. Not required any object, because this copy is common copy for all the objects. This copy is common copy for all the objects, and it will be there in the memory before any object is created. No object is no object is required to be created here. Right? So no object is required to create to access what? That B name. When the class loaded at the time, this B name is already loaded into the memory. So to access this, technically speaking, no object is required. I said what? There is a common copy. There is a common copy for all the objects, and actually to access this common copy, no object is required, because this should be there in the memory. It should be there in the memory before any object is created. And to access this, no object is required. Right? Getting me here? See this? No object I have created, still I can access this B name. And most of the cases we don't access like this. Right? I'm removing and I'm writing a very interesting statement here. If you want to access the static variables, because they are loaded at the time of class loaded, so most of the case we'll access them by using class name. What is this? Class name date variable name. So I started my discussion common copy with all the objects, but there is actually not required any object to access this. That is a common copy, absolutely fine. But to access this, no object is required. So directly you can access it by using its class name. It is same. You can absolutely access this by using its class name. Right? See this. Now it is valid. It is coming here. Getting me, guys? What I'm trying to explain here. That is the reason why I told you. This is the most mysterious. When will the static string B name will be used? Same thing. So this is what actually. So there are two ways to access it. What are the two ways to access it? I'm not saying that it should not be accessed with any object. There are two ways to access it. What are the two ways to access it? You can use the object reference, absolutely valid. You can use the object reference to access it. Or my point is, no object reference is required to access it. I am not saying you should not use the object reference to access it. So there are two ways to access these variables. One way is directly using the class name. The second way is what? After creating the objects also you can access it. Nobody stops you to do it. You can access what? B name with ACC1 object, because it is a common copy for all the objects. Because it is a common copy for all the objects, so you can access with what? Variable also. Reference also you can access. With the object also you can access. Without object also you can access. Because it is there already there in the memory, so that no object is required. Getting me? Now let's see what happens here. See, first time I'm trying to access with the class name, second time with the object, and third time again with the object. Yes or no? Right, so that is what here, that is what very interesting thing related to this. Now that is where we introduce, I will introduce one more new concept as I told you. So whatever the variables you will have inside a class, now inside a class, if you see my account class, I have written two different types of variables. What are the two different types of variables I have in my class? These are instance variables. What is the meaning of instance variables here? The memory will be allocated for those two variables when the object is created. Yes or no? And the memory will be allocated for this variable without any object. And the memory will be allocated for this variable at the time of class is loaded. Yes or no? At the time of class is loaded, the memory will be allocated for this variable. That is the reason why. So these variables are called as what? Class variables. Now you see in my program there are two different types of variables. So these two are called as what? These two variables are called as instance variables. Right? So these two variables are called as what? Instance variables. Account number and account name, these two are called as instance variables because the memory will be allocated when the instance is allocated. And this one is called as, this one, what is that? This one is called as class variable. Right? So in the class you can come across two different types of variables, instance variables and class variables. You need to identify the difference here. So it is very special requirement you have when to take a variable as static variable. In all cases we don't go for it. When to take a static variables. Most general case is whenever you have final variables, then it is always we go for taking what? Class variables. Right? So instance variables inside a class, you can create both type of variables. So static variables are, we call them as what? We call them as class variables. What? Class variables or static variables, both are same. Class variables or static variables we call, or we say as what? Instance variables. The second type of variables, since starting of Java we are learning, what is it? Instance variables. Instance variables, or we call them as non-static variables. Right? Very important interview point of questions, all this. Non-static. Instance variables or non-static variables are same. In the same way, instance are non-static variables, as in the same way class variables are static variables. Why we call them as class variables? Because we access them with the class names. We access them with the class names. Did you get what is these things? Fine? Okay. Right? Now we'll move on to what? Methods, static methods. What is these static methods are for? Very interesting point and important point here. What is a static method? I think no need to explain the static methods. Already since you are starting program of Java, we are using this such kind of one method, the famous method. What is it? Since first program, beginning program of your Java, we are using that famous method, static method. What is that? Main method. One somebody says public static, one somebody says void. Main method. Why main method is taken as static then? What is the reason behind taking a main method as static? Yes. Method signature, don't make mistake, method signature means return types and all will not come into the method signature. Method signature means what? Method name and parameters. Only those two are called as what? Method signature. Return types, access specifiers, modifiers, they will not come into the method signature. Why main method is static? The reason I am asking is why it is static. Again, very fundamental point inside this. As we keep on learning that, right? As we keep on learning that, if a class contains a method, yes, absolutely correct answer. If a class contains a method, that method should be called after object creation only. Yes or no? If you want to call the methods of a class, the class method should be called after creating the objects only. Now, when this object will be created, this is also a method. Main method is also a method from what class? Account main class. If I want to access this method, main method, when to create the object for account main class? Who creates the main object for account main class? Right? So without creating the object of a class, the methods of the class, if you want to call the methods of a class without creating any object, so in that case we make methods as what? Static methods. So in the same way how we have instance variables and static variables, in the same way you can have instance methods and static methods. Instance methods means what? The methods which should be called after the object creation, but static methods should be called without any object creation. Let's suppose, for example, only I am writing static void method, right? It is not always that you should call the methods of a class with class name only. No, there is always such kind of requirement is there. If you, without creating the object also, if you want to call the methods of a class, then in that scenario make the methods as what? Very important point, and we'll see this kind of methods later. System data out dot println. Absolutely calling this method with object is allowed, no problem. Absolutely calling this method with object is allowed, right? Because static method, right? Just I'm writing now how to call this method. If you want to call this method, so how to write a static method without any with a static keyword? Attaching a static keyword to a method signature is called as what? So there is nothing but a static method. Now if you want to call this, just you need to use again the same story, class name dot method name. That's it. Class name dot method name. You cannot call directly a method name here. If both are there, class name dot method name, because I am trying to call this method outside of a class. Outside of a class I am trying to call it. So when you try to call this outside of a class, you need to use the class name. If you try to call this method inside of a class, then no need of class name. If you try to call this account, this method inside the same class, no need to use a class name. But I am trying to call this outside of a class, definitely require class name. See there, my method is executed or not? Static method. You can see the output here. Is it executed? No object created, nothing. Just I am trying to execute this with the class name. It is possible. Now, why main method should be taken as, why main method is static? That is the same reason. Because it is also a method of a class. It is also a method of a class. To access the method of a class, where to? Who is, first of all, who is trying to call this method? The virtual machine, the Java runtime is trying to call this method, right? The Java runtime is trying to call this method. Now, how it is going to create the object for this class? It's not possible. So that is the reason why to call this method directly, the virtual machine uses what? The Java runtime uses the class name. Class name dot main. This is the reason why main method has taken as static. The one example, good example. So very important interview question. Why main is static? Because it should be called, it is called by some Java runtime, and it should call this method without creating any object for the class. So that means this should be, it is possible only when, yes, account main dot main by JVM. Not only account main dot main, but it also passes the string argument. String array is there, see that. It's not only calls the main, it should pass a array of string. Otherwise it is not unable to call. If you call or if somebody calls, the story is same. Only one way to call this method. Class name dot main by passing string array. Yes. That is also wrong. That is passing two string values. That is not array. Two different string values. Passing like that becomes two different string values. That is also wrong. You need to bind them into one array. How? Simple. String array, I already discussed the arrays. I think you missed that class. Create a string array. Right. So whatever the variables you have taken, bind them into the array. Now this becomes array. Previously whatever you have used two different strings. Now you can pass them. String, oh it's not, variable is missing here. Now this is becomes a string array. Now pass it to main method. This is how we should pass. When you pass independently, what is that? That is string s1 is equal to 1, hello, string s2 is equal to 1 more. That is not an array. Okay, understood? Yep. Absolutely, this is now, that is the one I am saying. Right, so this is what here the importance of static methods and static variables, right? So now let me write one more last one, static block. Just I would like to write static block means a block with a block with what? Static keyword. Same like a method with a method means what? A block only. In the same way you can have static block. Just I'm going to write nothing here. I'm just adding one static block here inside this. Right. What is this? Static block. Now let me run my main class. What is going to see here? It's compiled. See here. What is the first one which is executed? Very important point. Static block is executed first, and that is the meaning of static block. Static block will be executed at the time of, so at the time of class is loaded. At the time of class is loaded, there some code will be executed. Without main method also some code can be directly executed. See here. Now I'm not going to write anything here in this main. Right. I'm calling a account.method. I'm not calling anything here. Just I'm calling account.method. So I should get the output from what? Account.method, and remaining every code I'm making comment. I'm just making every statement of my class comment. I'm putting in comments here. Now I'm calling account.method. So what should execute here? It should execute this one from my account class. Is it the same thing is going to happen? Let's see here. Is it executed only method? No. At the time of class is loaded, some code you can execute. So at the time of class is loading, if you want to execute some code, you can execute. So here, very important, this class, these two methods are executed without any object creation. That is the first point you need to understand here. Whatever the two statements I have seen in my console, they both are executed without any object creation. See, they are executed without any object creation. Right. So static blocks are, we have some usage with the static blocks. First one point you can say as static blocks are used for initializing static variables. There is a one usage I can say. But it takes some time to understand what is the use of static blocks. When we discuss JDBC kind of course, there you can discuss about it. But till at the time of your class is getting loaded, right? If you want to execute some code, just we write that code in the static block, right? So we come across different variables and different methods today. So not only instance variables, instance methods you can write inside a class. You can also write what? Class variables and class methods. Very careful. The variables which should be called by the class names and the methods which should be called by the class names, they are called as class variables and class methods. Getting me? There's a very new concept here we have. As already I told you, beginning of the Java classes, there are three types of variables are possible: local, instance, and class variables. So this is the third category of variables: class variables and class methods. Right. So before winding up this session, I would like to tell one point here. So you can have a class can have what? Combination of both. A class can have combination of both. What is the meaning of combination of both? A class can have non-static things as well as what? Static things. This is a non-static one. Method one. What is this? This is a non-static method because it does not have any static keyword attached to it. So it becomes a non-static, and this is a static. And the one more important technical point here is a static block or a static method can access only static. Just remember these points. A static block can access only static. Means what? I can access only static means what? I can access only bank name here. I can access only bank name because bank name will be there in the memory before this method is executed. But account number and account name will not be there in the memory. Getting me? Only the bank name will be there in the memory when this method is called, when this method is loaded. But there is no account number and account name will be there in the memory because these variables will be loaded in the memory when the object is created. So that means what? A static block can access, static method can access only statics. But a non-static method can access both static and non-static. Just remember this point. Simple to remember. Static can access only static, and a non-static will access can access both static and non-static, just because of memories. One will be allocated the memory bus and the other one will be allocated the memory when the object is created. So static can access only static, and non-static can access through this method one. I can access all, everything I can access of the class from non-static. Getting me? So this is what important here you have. So this is one more type of variables you have. They are static variables, final and static keywords. Fine. So I would like to stop this session today here, so that tomorrow we'll discuss some other. And you have still some other access modifiers I have described here. Still you have some other access modifiers. So these access modifiers we'll discuss when the time comes. So here the synchronized and volatile are used in multi-threading. Transient is used in IO. So like this, these keywords we'll see later. And no, strict FP nobody are using these days. It is almost out from Java, right? So synchronized and volatile we will discuss with multi-threading, because the usage of those two things will see in multi-threading, right? Okay, then if you have any questions you can ask, otherwise we stop the session.